Alright, so right now we're going to be doing the section F.LE.4. So, equation asks, find the amount of water vapor that will saturate 1 cubic meter of air at temperature of 50 degrees Celsius, found round to nearest tenth of a gram. Alright, so you have all your numbers here. So you're gonna want to go to your calculator. Get your calculator out. Then you're gonna go to stat, enter, and then you have all your numbers entered in here. So then you're gonna go to press second stat plot. Click enter. Click the first one, and then make sure that it's on. Enter. Then you want the scatter plot and this L1 and L2 for your X list and Y list. And this, I just like to use this square mark. So then you're gonna go to window, make sure your window's all set. So since our X minimum is -20, I like to set it a little bit below that. So I'll go -25. And then our X max is, our X max is 40, so I'm just going to put it at 50. And then our Y minimum is 1, so just put that at 0. And our Y maximum is 50, so just put 60. Alright, and then you're going to graph it, see what it looks like. So yeah, your graph should look like this with your scatter plot. And then you go back to your stat plot. Or, sorry, no, you just go back, press stat. Scroll over to calc. Go down to, keep going down to 0. Exponential REG. Press enter. Then you're going to go all the way down to calculate. Press enter, and that will give you your equation. So you have 4 point, we're going to round it to the nearest thousandth. So that would be to the tens, hundreds, thousands. So it would be 4.194. So alright, so 4.1, shoot, 194. 194 times 1.068. 1.068 for the X. And then you're gonna have to solve the equation for the temperature at 50 degrees Celsius. So you can make it. So you can do 4.19 times 1.068 to the 50th power. And you're gonna plug that into your calculator. Oh my god. Alright, plug that in your calculator. So 194 times 1.068 to the 50th power. Alright, and you should get an answer really similar to this 112.5. And you're going to round it to the nearest tenth of a gram. So that's 112.5. So that's how you do section F.LE.4. Alright, now we're going to move on to what the hell? Alright, we're going to move on to this one right here. I mean, you can't. Okay. Can I like pause it?
Yeah, pause it.
So the next problem that I'm going to do is finding the limit notation of a function. So the 32 is the y-intercept. So that is where the graph crosses the y-axis, and then you can tell it's decay because the second number is less than 1, and because it's 0.5 less than 1, that means it's a 50% decay. So I can write that. And so how you find the limit is you check on how the line goes. First you check how it goes on the y-axis, then the x-axis. So the limit of this side will be so the limit of f(x) of this side right here will be, so the f of x is y. So the y, it's always gonna go towards 0. So the limit is 0. And then the limit of x is going toward infinity. So x equals positive infinity. And the limit for this side is the y goes to infinity, it's going up, so y equals positive infinity. And then the x will always be going this way, which is negative, so x equals negative infinity. And that's alright, the next function, or the next standard I'm going to do is so this one is writing a function in different but equivalent forms and identifying the percent rates of change. So I'm gonna grab my equation. So my equation is x equals 2 to the 1 to the x. Alright, so how you do this is, well, I'm just gonna plug in 4 for x. So you have so you can actually have an answer. And then, so you can, first you divide by 2 to get it out of there. So it's gonna be 2 equals 1.5 to the x. And then because you can't divide by if it has an exponent, so you're gonna do log of this because it's an exponential equation. So you're gonna do log of this. So you do log of 1.5, log of 1.5 2 equals x, which we just said is 4. So then you're gonna do, since you can't divide this either, so you're gonna do log of 2 divided by log of 1.5 equals x. And then I'm gonna get the calculator. Alright, it stopped recording, but this equals x. And so first you do log of 2 divided by log of 1.5. And then you enter that, and it equals 1.7. So 1.7. You can round it to thousands, but about 1.7 equals x. Alright, I'm redoing that problem. Because I don't know how to delete it, so I'm gonna do. Guys, I'm recording. Alright, so this is standard F, I, F, 8, E. And my problem is. This is my problem. So what you have to do is, so x is the amount that you're gonna see. What this is, so this is time exponential growth. So this is the amount of time. So I'm just gonna put in a random amount. X equals 2. So you're gonna want to figure out how much time it takes to get to 4. So you can divide by 2, and that's equal 2 on this side equals 1.5. And then you have to, since this is an exponential form, you can convert it to logarithmic form. So that's how you do that. And you're gonna put x. You don't know because you don't know the amount of time yet. And you can do log of 2 divided by log of 1.5 equals x. X is the time. And then you can probably use a graphing calculator for this. And I've done it right here already. So log of 2 divided by log of 1.5 equals 1.7, about 1.71. So that's the amount of time that it takes to get to 4.